In this video, we want to prove the triangle inequality that says given any two sides, the length of those two sides must be greater than or equal to the length of the remaining side. The way we're going to start the proof is with x plus y quantity squared. This is equal to x squared plus 2xy plus y squared. Now, we know that x is going to be less than or equal to the absolute value of x, and y is going to be less than or equal to the absolute value of y. So we can find something that is bigger than or equal to this by replacing x with absolute value of x and y with absolute value of y. Notice that x squared and y squared are exactly the same as absolute value of x squared and absolute value of y squared. The only difference is with 2xy. This could be sometimes negative, whereas this is always going to be bigger than or equal to 0. Okay, now we started off with x plus y squared. We'll call that equation 1. We simplified it to equation 2, which is x squared plus 2xy plus y squared. And we found that to be less than or equal to this, which we'll say equation 3. So we have 1 is equal to 2, which is less than or equal to 3. That means 1 has to be less than or equal to 3. So x plus y quantity squared is less than or equal to the absolute value of x squared plus 2 times the absolute value of x times absolute value of y plus absolute value of y squared. Okay, now we can factor out the right side. This is just the absolute value of x plus absolute value of y quantity squared. And all that we have to do is just take the square root of both sides. So the question is, what is the square root of both sides? Well, let's consider the absolute value, or the square root of negative 3 squared. We know first that the domain and range of the square root function is x and y both have to be greater than or equal to 0. Many students will say, well, the square root undoes the square and you end up with negative 3. That's wrong. Negative 3, first of all, is not part of the domain nor the range. So you always want to make sure to take the absolute value of whatever is inside. In this case, it's going to be the absolute value of negative 3, which is positive 3. Same thing here. X plus y can be negative. So you want to make sure when you take the square root to put the absolute value for x plus y. Now with the absolute value of x plus absolute value of y, we know that each one of these is going to be greater than or equal to 0. So when you take the square root, it's still going to be greater than or equal to 0. So you don't need the absolute value. So to explain further, what I'm saying is that these two are equivalent. Since this inside is greater than or equal to 0, this is greater than or equal to 0. Okay, and so this completes the proof.